I'm here with Bob Wainwright, and we are perform a full analysis on the world record discus thrower by Alekna. So this is the analysis. This is our APA system that consists of so many applications. So we have a capture, DV, all the things that you see on the screen, and display, and the full analysis that we can do with the APAS analysis. Usually you start with capture DV, but we already got the video right now just for demonstration, because it takes some time. We'll open it. It will take a few seconds. Here it open it. And the idea is to decide where is the beginning and where is the end. So we click on it and we'll go start running the video. And you see the video a little bit squashed, but we can expand it so it will look like 196 centimeter tall. We got the video from Christoph. It was very nice for him to allow us to use the video so we don't create problem with copyright. So we'll let it go and we decide where we want to start the analysis. So we'll go there, it's still going back, and at some point I'll stop it. Okay, so I'll go now frame by frame to find where he start. Okay, he's moving, so I was starting it right properly. Okay, and I'll decide that that's the beginning. So I will trim it to the beginning. So this is the beginning. Now I have to find the end. So I'll keep going. This is the portion of the video that we're going to analyze, and we're going to synchronize it with the other video that we have, or multiple videos. So we'll keep going here to the end where we decide is the last frame at the release. So here is going, and stop it around here and go frame by frame where we just released the discus. So we go back and I'll trim it here for the end. So that's the end. So now if we go back here and we'll go to the beginning and to the end, we'll have exactly only the portion that we want to analyze, because we already did the other one. One thing that we have to do is also synchronize the video. So in order to synchronize, we just push the sync here, and it will sync one video with the other video. But in this case, I just said the one. If I go to and open the file, the other file, file, open AVI, and I'll take the one from the side. So next module, I'm going to the digitizing. And there are many ways to do digitizing, manually, automatically, or we are working now on AI also to do it even better. But I'll show you how we're doing it with the APAS right now, which is quite sophisticated. So I'll go to digitizing, and I'll open the file. This is our project, which is Alekna Discus. And it showed that the computer find segments based on models and everything else, including we had to define the discus. So, and from here, we like it to automatically digitize the whole motion. So for that, I'll go out of here. And go to go for example to the stick figure. And now look what the amazing program doing. it automatically finds the segments. And these are the segments that give us all the kinematic parameters, the displacement, the velocity, the acceleration, the power, the forces. All we can calculate from here. So here we're going through the whole process for the file that we trim and define. Now it finds all the stick figure here, and it will stop in the end. And that's not too bad. We had some problem with calibration point and things like that, but that's good enough. So now I'll stop it here, and from here we can do a whole analysis on the system. So I'll stop it here and then go to the other module. So the next thing we want to do is to analyze the data. So we'll go to display that give us a lot of things that we can do. So in this case, I would load first the stick figures. So if I go to the stick figure, and I want to put it in a multiple, so I do tools, view. I'll put it in a multiple. So now, basically you see the stick figure. Each frame going within all the stick figures that the computer defined. Now from there, we can calculate different kind of data. What kind of data we can calculate? So if I go to the 3D and open the file, new 3D, and now this is the most important thing in the whole APAS analysis. We can make linear measurement, segment angle, joint angle, length, segment linear, raw position, displacement, velocity, and acceleration. And we can use any segment that we did, including the discus, which is in the end. So let's say I want to know the velocity of the discus. It would be very interesting, right? So I'll go linear velocity, and I'll go to the discus. And I can do it in the X, Y, or Z, or 3D. I'll do it in 3D. And I'll say, okay. And I'll graph it, data. And here I can do lots of modification. I can smooth it a little bit, all that, but I won't touch it. I say, okay, and here's the data. And look what happened if I add a stick figure here. Tile, and I'll do the tile. And now I'll add the stick figure here. First I'll show all the data. It will show me. So look on that. On every segment, it would, at every position, it tells me the velocities calculated from the data. But I'll put the stick figure here, and give it again, okay. And then if I want to know what is the velocity here, or I want to see how the person look in this deal, I can put also the picture here. So I will go to the here and select it, open. So here is the position, cascade, no, window, tile. So now I have everything. So now if I go forward, you look on the position and you look on the velocity. If I want to stop here and to see what is the velocity here, either I can find it in the data or find it here, or if I want to know what the velocity in the end, I'll keep going. Just in the release, which is here. And since it's 120 frames per second, the centimeter per second is wrong because, but anyway, but you see the pattern, but we don't have the proper frames per second. I guess here it showed that is 600 centimeters per second, but probably you have to multiply by 4 because it's 120 frames per second. It's assumed that it's 30 frames per second, but it's really 120 frames per second. So anyway, and here you see every position. It will tell you what the velocity is. The most important thing, you see the acceleration in the end that reaches the most velocity. So it would be interesting also to calculate what the acceleration, put the curve there. So I'll go again to new 3D. And in this case, I'll put acceleration. And I'll take the discus and 3D. Okay. Graph, data. Okay. And now we have acceleration curve. I will window tile it. So now you see what happened with the acceleration. And you see that the various things happen in different segments here, and then tremendous acceleration to the release, which makes sense. Here, and I show you the video exactly where each position is. So maximum acceleration was here. Because he's in the air already, his feet in the air, as you see. The acceleration went down on the discus. But I can look on the acceleration of the leg, and any parameters you want to measure now, you can measure from the APA system. One thing that is very important is to know what is the velocity of the leg, the left leg. Would the left leg stop at the release, before the release? So I'll go to new 3D, and I'll take linear velocity, and I'll go here to that's the left foot, I'll go to the right foot. Yeah, left foot. Yeah, left knee, left hip, I'll put also left hip, left ankle, left foot. In 3D, and I say okay, and I graph it, okay, and then I'll panel it, tile it. So now, when I look on the left foot, look what happened here. The left foot, need to look, these are all the segment of the leg. But you see that if I go to here and look on the picture, look on here. That's when the left foot actually stopped this point. And the stop of the left foot obviously apply energy to the upper body, which we can measure also. But you see here the demonstration of how many things can be done with the APA system. If I put the acceleration of the leg, just let's do that. So new 3D, and put the linear acceleration of the right foot, right ankle, not right, I want the foot, I'm sorry, the left hip, left knee, left ankle, left foot. And in 3D, I say okay, and I'll graph it, and I'll tile it. Look very similar, both of them, but this is acceleration. So if you look here, you see here, there is a tremendous deceleration. This is the impact. Look on the picture. Get maximum and the acceleration, then decelerate. Deceleration of the lower body give energy to the upper body. And of course, when the discus leave, there's no more acceleration there. But you see all these parameters and all the curves, and you see the pattern of the front leg. And maybe I don't do everything very accurate here because I'm demonstrating really a little bit fast. But you see the power of the APA system that you can analyze almost any performance. One thing which is very important, how we interface this kind of information with the coach. So yesterday we had the gold medalist and world record holder in the past visiting us, Mac Wilkins, the gold medalist from 1976 Olympics. We are friends for many years. I used to coach him also for quite a while in Dartmouth College, started in 1970. Anyway, so we want now to integrate the data of velocity, for example. That's what Mac asked us here yesterday, of the discus in velocity and acceleration. In various points. So now, if I keep going, and you see the data is strobing there, and at some point, I want to know what the velocity of the discus and the foot, the right foot came up off the ground. So I'll go frame by frame. And the data show here and show here. So I'll keep going. We'll see when you leave the ground. And this is one of the questions among many that Mac asked us. It was very important for him to know the velocity of the discus and when the right foot left the ground. So it's almost there. The right foot, right? The right foot. Yeah, okay, one more, that's it. Or even one more. Doesn't make difference. Okay. So here you look, it's a, here you have the 3D centimeter per second. That's the time, and it's the value, 127 and 271, and you see it on the curve, on the acceleration. And here you see it on the curve. If you know another position, it will show it to you. So it will show you every position that you want to know the relationship between the segments and the athlete. So one of the fascinating thing with the APA system, that now can we predict the distance based on the trajectory, angle, and the velocity of the discus. Obviously, there will be some discrepancy here because all kind of aerodynamic thing on the thing. But based on our measurement, how far the discus will go. This is quite amazing. So I'll go to the display and I select the stick figure. And you see the stick figure going here. And that's like before, you saw it before. This is the one that we trimmed. And now I want to know how far the discus will go based on this velocity and all the parameters that we measured before. And that will be quite amazing. So here we have a thing, how far this discus will go. So for that, I'm going to this triangle here. And I select the discus. I say, okay, And this is the miraculous things. The angle is 28 degrees, which is straight, so this is 0 degrees, 20 degrees in the release. And the distance is 74 meters, 41 centimeters. He was 74, he was about that, but then the measure is 73 something, I don't know. But anyway, that's the trajectory where the discus could go. Of course, there is aerodynamic there and all kind of air resistance and things like that, and maybe increase. But it predict the distance. So that means that our formulas and our model working pretty good. And this is from YouTube, don't forget, from YouTube, from the screen. We didn't have the original video in the Throwing Academy. So then we'll have it even more accurate data, but that's good enough for me. So we are very, very happy with that. So thank you for your presentation, and thank you for your patience to be able to listen to all these things. We'll see you in my next birthday. Yesterday I was 85 years old. So we'll see you when I'm 86 and we're still around. Bye-bye.